Last week in Japan, people were stunned when a man climbed inside a giant glass sphere and rolled right through rush hour traffic. In Poland, a bike with no wings lifted a pilot 600 feet into the air using technology that seemed impossible just a few years ago. And in California, drivers on Highway 101 watched as a car left the road and flew above it. These machines are no longer futuristic concepts. They are real, fully working vehicles that could soon be delivered straight to buyers. Each one represents a different step towards solving the same challenge, making personal flight as simple and affordable as driving a car. At the end of April 2025, Tomasz Patton shocked the internet with a short video that went viral. It showed a sleek matte black flying machine swooping low over a wooded valley in Poland before landing softly on a dirt trail. Many thought it was computer graphics, but it was very real. The machine, called the Volonaut Airbike, was developed in secret over 2 years. Patton, who co-founded the Jetson 1 flying car, worked on this new project without revealing it to the public until now. What makes the Volonaut Airbike so different is how it takes flight. Unlike drones or helicopters, it doesn't rely on spinning rotors or wings. Instead, it uses tiny jet turbines hidden inside a razor-thin carbon fiber frame. This frame, made with advanced 3D printing, is 7 times lighter than a regular motorcycle but strong enough to survive the stresses of flight. The pilot sits on it like a motocross bike, leaning forward with a clear, unobstructed view in every direction. Since no blades spin nearby, the experience feels clean, futuristic, and completely open. The bike's movements are controlled by a high-tech flight computer. Even the slightest change in the rider's weight or pressure on the handlebars causes the nozzles to adjust, keeping the airbike balanced whether hovering in place or racing forward. According to Patton, it can reach speeds of nearly 124 miles per hour, yet fly quietly enough to move through city streets without creating the loud, swirling wind of helicopter blades. On a single tank, it can stay airborne for about 20 minutes, enough time to cover a 10-mile radius and completely change how people might travel short distances. Experts estimate the machine weighs less than 90 pounds, giving it more power and control than many racing drones. Patton hasn't revealed the full details of its turbines yet, as he is securing patents, but many systems on the bike, like the pilot's helmet and electronic controls, are based on proven technology from the Jetson 1, which already sells for around $128,000. The test footage shows the airbike cutting through tree lines, hovering above forests, and darting through narrow gaps that no helicopter could ever attempt. Its stability in windy conditions amazed tech reporters in Poland, who believe it could be used in future rescue missions or difficult terrains. Although no official price or release date has been announced, excitement is growing quickly. Investors, first responders, and city planners are already imagining how a compact flying machine without rotors could transform daily life, whether for rooftop landings, pipeline inspections, or turning long commutes into 10 minutes of flying freedom. Patton has promised more test flights soon, including one over a major city skyline. As groundbreaking as this flying bike is, it was not the only futuristic vehicle revealed in April. Toyota engineers introduced something equally strange and fascinating in Japan, a transparent drivable sphere. During a live demonstration, crowds gathered to watch what looked like a giant crystal ball rolling smoothly across a test track. Standing over 6 feet wide, the clear bubble contained a small 2-seat capsule at its base. With a simple push of a joystick, the sphere rolled forward like a futuristic hamster ball. The engineers, part of the Toyota Engineering Society, built this full-scale working model in only 4 months, starting from a small hand-sized concept. The crystal-clear surface was created by a Japanese company called Shinsha, known for making thick acrylic walls for massive aquariums that hold sharks and other sea creatures. Using careful heating, polishing, and fusion techniques, they built curved panels that join together seamlessly, giving the globe its flawless transparent look. Despite its size, the sphere weighs only around 400 pounds, light enough that 2 people could roll it by hand. Inside, the design is simple but clever. The capsule always sits at the very bottom of the sphere, so gravity naturally keeps the riders upright without the need for seat belts. To move, 4 rubber-tired wheels push the sphere forward, giving passengers the feeling of gliding inside a moving glass world. The clear Sphere car from Toyota is built around a clever inner cart. This cart holds 4 small wheels, each one powered by an electric hub motor already used in Toyota's other vehicles. In its very first test runs, the Sphere barely moved, crawling forward only about 10 feet. But after software updates, its performance improved a lot. Now it can travel close to 10 miles per hour and even spin completely in place with a perfect zero-turn radius. This makes it especially useful in crowded city areas where space is tight and precise curb-to-door movement is needed. The transparent acrylic design gives passengers a full wraparound view of their surroundings, almost like floating inside a moving bubble. But Toyota engineers are already thinking ahead. They are working on future versions that will use smart glass instead of plain acrylic. This new material would automatically darken under strong sunlight and also show useful information on the dome itself, such as speed, battery level, and even navigation directions. Despite the excitement, Toyota has made it clear that this unusual vehicle won't be sold in dealerships anytime soon. Right now, it doesn't meet the safety and performance requirements for public roads. It has no suspension system, little crash protection, and not enough grip for wet or slippery conditions. Instead, Toyota is limiting it to their experimental smart city called Woven City, built at the base of Mount Fuji. Woven City is a special place where normal traffic laws don't apply, and it's designed for testing futuristic technologies like delivery robots, self-driving pods, and now the rolling glass sphere. Engineers are also working on making the ride smoother on hills and experimenting with new lithium iron phosphate batteries that could stretch drive time to over 30 minutes per charge. While Toyota was experimenting with spheres, another company was working on solving a much bigger challenge: how to create a vehicle that could move easily both on the ground and in the air. In January 2025 at the CES show in Las Vegas, a Chinese company called RTOR stunned the crowd with a live demonstration. They revealed the Skyrider X1, a sleek matte black scooter that looked like an ordinary electric moped at first glance. But within seconds, it unfolded 4 carbon fiber arms, each carrying 2 stacked propellers, and lifted straight into the air. Unlike many futuristic concepts hidden behind glass, this was a working machine on full display. The Skyrider X1 combines 2 things in one: a street-legal electric motorcycle and a vertical takeoff aircraft. Once it takes off, the wheels fold into the body, and when it lands, the arms fold back in, returning it to the size of a normal motorcycle. This makes it practical for weaving through city traffic, parking in regular spaces, and recharging at existing roadside stations. During test flights, the X1 climbed to an altitude of over 650 feet and cruised steadily at around 62 miles per hour. Depending on the battery pack, it can stay in the air for between 25 and 40 minutes. The standard SEL version provides about 25 minutes of flight, while the more powerful SX version pushes that closer to 40 minutes. With the longer flight time, the X1 can cover nearly 40 miles through the air. That means a journey like San Francisco to San Jose could take less than 15 minutes, while the same trip by car during rush hour could last 2 hours. On the ground, the hybrid electric motor extends the range even more, giving it up to 112 miles on a single charge. The entire body weighs only 176 pounds, which is actually lighter than many motorcycles, yet it's strong enough to carry a person weighing up to 264 pounds. The frame is built from a mix of aluminum and carbon fiber, making it both lightweight and durable. RTOR designed the Skyrider with safety as a top priority. A triple redundant flight computer controls weather detection, navigation, and takeoff and landing. Even if all motors were to fail in midair, the X1 has a built-in ballistic parachute that deploys automatically to bring it down safely. For pilots, flying it feels surprisingly familiar. The throttle works like a dirt bike to control climbing, and the handlebars tilt to rotate the craft. For those who prefer less manual control, the autopilot system can take over, with a heads-up display guiding the journey. In a test flight over Lake Mead, the Skyrider switched from driving on the ground to hovering in the air in under 10 seconds. It even avoided floating obstacles on its own and landed smoothly on the shoreline using amphibious landing skids. The Skyrider X1 comes in 2 models, priced between $50,000 and $60,000. much cheaper than earlier hover bike prototypes that cost over $1 million. Demand has been overwhelming, with pre-orders selling out in just 48 hours. And with China planning to open special low-altitude air corridors above Shanghai in 2026, this could mean daily commutes in the near future might literally include flying through the clouds without needing to change vehicles. Since 2008, one company has been working hard to build a safe and reliable personal jetpack, and their story has been full of unexpected turns. Back in 2008, at the Oshkosh Air Show, the crowd was surprised when a strange machine made of carbon fiber and aluminum rolled out. It looked like something from an old science fiction movie. This was the Martin jetpack, created in Christchurch, New Zealand. Unlike the dangerous rocket-powered packs seen in movies, this one was built to be practical. It ran on a 2-liter V4 two-stroke gasoline engine that produced about 200 horsepower. Instead of fire, it used 2 duct fans that pushed cool air downward, lifting both the pilot and the machine straight up into the air. Over time, more than 30 prototypes were built, each one improving on the last. The final version looked surprisingly realistic for everyday use. It weighed about 441 pounds when empty and could take off with a maximum weight of 1,135 pounds, which meant it could carry a person and equipment weighing up to 265 pounds. It was able to fly at speeds of around 46 miles per hour, climb to heights of more than 8,200 feet, and stay in the air for about 30 minutes on 1 tank of fuel. For safety, the jetpack was equipped with a ballistic parachute that could deploy in less than half a second if something went wrong. The fly-by-wire system and controlled thrust made it steady enough to hover near tall buildings or stay fixed in the air over cliffs. This stability made emergency response teams very interested. In 2015, Dubai Civil Defense even ordered 20 units, believing that jetpacks could help firefighters reach the top floors of the Burj Khalifa faster than any ladder. Military groups and other first responders around the world also saw the potential. The biggest problem, however, was not the engineering. It was the funding. Between 2014 and 2017, a Chinese company called Guangqi Science invested tens of millions of dollars into the project. But development costs kept rising, and by mid-2023, the company no longer had enough money to continue. In July of that year, Martin Aircraft was shut down, and its equipment, prototypes, and design files were put up for auction. One prototype was sold for $158,000. Soon after, an unnamed international buyer purchased everything else, including the rights to continue development. The timing was very interesting, as it happened just when the FAA in the United States was preparing new rules for powered lift aircraft. Whoever bought the designs clearly saw an opportunity. Analysts believe that the Martin jetpack still holds the record for the best payload-to-weight ratio of any duct-fan jetpack ever built. Engineers working with the new buyer are now exploring ways to replace the old gasoline engine with a quieter and more efficient hybrid turbine electric system that could offer longer range and lower noise. If all goes according to plan, new test flights could happen by late 2026 under FAA drone regulations. This time, the Martin jetpack may not return as a luxury toy for the rich, but as a machine designed to save lives, capable of reaching the 30th floor of a skyscraper in under 30 seconds. While the Martin jetpack waits for its comeback, another company has been working on a very different idea, making flying as simple and effortless as riding a ski lift. At the World Expo 2025 in Osaka, a futuristic aircraft with spider-like legs amazed the crowd as it lifted gently into the air, floated over a still pool of water, and landed almost silently, showing the world another possible future for personal flight. The Hexa is a one-seat electric multicopter created by a company in Austin called Lift Aircraft. Unlike what some early reports said, it doesn't have 8 propellers. It has 18, with each propeller powered by its own motor. These motors run on energy from quick-swap lithium-ion batteries, which give the aircraft around 15 minutes of flight time, plus some reserve power. During that time, Hexa can cruise at speeds of up to 63 miles per hour and reach heights of about 1,200 feet. Its frame is made from lightweight but strong carbon fiber, fitted with floating pontoons so it can land on water, and it even includes a ballistic parachute for emergencies. The entire design stays within the 254-pound weight limit set by the FAA's Part 103 rule. This is important because it means that anyone in the US can legally fly it after just a short virtual reality training session. No pilot's license required. Japan was actually ahead of the US in testing the Hexa. In March 2023, Lyft partnered with Japanese trading giant Marubeni to carry out the first crewed flights near Osaka Bay. These tests proved that Hexa was surprisingly quiet, producing noise levels of less than 65 decibels from 50 yards away, about the same volume as a normal conversation. Since then, more than 200 people ranging in age from 16 to 72 have trained using VR simulators that copy Hexa's single joystick control system. Most first-time flyers describe the experience as being closer to playing a video game than flying a real aircraft. The aircraft's triple redundant flight system manages the difficult parts like stability and battery usage automatically, so the pilot only needs to focus on the fun part, flying. Unlike traditional aircraft manufacturers, Lyft doesn't sell Hexa to private owners. Instead, they operate it like an amusement park ride. In March 2024, they began offering flights in Florida for about $250 per session. Visitors to the Osaka Expo can now book 10-minute Skyline rides directly from the Smart Mobility Vertiport. To make the experience accessible to everyone, organizers also introduced an AI-powered suitcase that guides visitors to the launch area with voice prompts, so both sighted and visually impaired guests can take part. Lyft's founder, Matt Chasen, has big plans for the future. He says the company is already working on permanent flight zones in places like Lake Tahoe, Austin, and Okinawa. These areas will function almost like zipline parks, but in the sky. Safety has been carefully built into Hexa's design. Even if up to 6 motors fail, it can stay airborne. And in the worst-case scenario, the parachute can deploy in less than 0.6 seconds to bring the aircraft safely down. With the FAA's new powered lift regulations being rolled out this year, experts believe thousands of aircraft like Hexa could be flying in low-altitude corridors before the end of the decade. The Hexa makes flying feel simple, exciting, and safe, almost like a game. But while Hexa focuses on easy recreational flight, another invention is tackling a different challenge. Making a vehicle that can drive on the road and then take off into the sky, skipping airports altogether. Reservations for the PAL V Liberty opened in May, and within just 6 weeks more than 300 orders have been placed, adding up to over $150 million in potential sales. With rotor production now fully industrialized and a dedicated assembly line already set up, the company expects the first Liberty vehicles to be delivered from Breda Airport before the end of 2026. The Liberty is already impressive for being able to transform from a road car into an aircraft in only a few minutes, but the next innovation takes things even further. It's a vehicle that can actually fly sideways. On June 6 in San Mateo, a crowd gathered at an old missile battery pad to watch something that felt like it came straight from a science fiction movie. ALF Aeronautics revealed its latest Model A prototype, and for the first time in public, the car not only drove like a regular electric vehicle but also took to the skies. The futuristic coupe rolled quietly along the road, then rotated 90 degrees, activated 8 hidden propellers, and lifted into the air. In that moment, ALF's vision of drive first, fly second, became reality outside the lab. This achievement came nearly 2 years after the FAA granted ALF the first ever Special Airworthiness Certificate for a street-legal electric vertical takeoff and landing (eVTOL) aircraft, allowing them to test flights over California farmland. At first glance, the Model A looks like a rolling piece of art, with a design that resembles an Art Deco-inspired mesh sculpture. But hidden within its frame are 8 electric motors with carbon fiber propellers. The distributed thrust design reduces noise and keeps the vehicle light enough to meet the FAA's Part 103 ultralight rules during testing. The production version of the Model A will weigh about 850 pounds when empty, have space for 2 adults, and still leave room for luggage. Its frame is built from lightweight composites, with a structural battery tray designed to handle extra load. On the road, it behaves like a small neighborhood electric car, with a top speed of around 25 miles per hour to stay within legal limits. But the real magic happens when the driver taps the fly button on the steering display. The system automatically checks surrounding airspace, locks up the front wheels, and shifts the propellers into vertical lift mode. Once it clears buildings, the body rotates sideways, transforming the car into a compact flying wing. In the air, the Model A can cruise at about 110 miles per hour and cover up to 110 miles per flight. On the ground, its electric drive gives it a range of about 200 miles per charge. Interest has been enormous since reservations opened in late 2023. ALF asked for only $150 for a standard reservation or $1,500 for a priority spot. By May 2025, more than 3,400 pre-orders had been placed, worth over $1 billion in potential sales. The first deliveries are expected in late 2025, pending final FAA certification. To prepare, ALF has already leased an 80,000 square foot facility in San Jose and is exploring Texas as the site for a second factory, aiming to produce more than 10,000 vehicles per year. CEO Jim Duchovny has even hinted at future models, including a 4-seat Model Z sedan that could travel over 300 miles in the air while staying in the price range of mid-level electric cars. For now though, the Model A delivers on its groundbreaking promise. The ability to drive through traffic, take off vertically, land directly in a store parking lot, and then drive the last block home, all without switching vehicles. While ALF has conquered sideways flying cars, in Japan another company has taken an even bigger step forward, unveiling the world's first certified flying taxi. The production-ready SkyDrive SD05 is a compact flying taxi that measures just over 37 feet in both length and width, while standing under 10 feet tall. Its sleek clamshell-style cabin can comfortably seat a pilot and 2 passengers, giving it the feel of a futuristic air car. The aircraft is powered by 12 quiet electric rotors arranged in 6 coaxial pairs, designed not only to provide lift but also to ensure safety. Even if one motor fails, the others can keep the vehicle airborne long enough to land safely. SkyDrive currently lists a cruising speed of around 62 miles per hour, with a flight range of 9 miles and a flight time between 5 to 10 minutes. However, engineers have already revealed that new battery systems in development could extend that range to between 19 and 25 miles within the next 2 years. At the Advanced Air Mobility Pavilion, visitors can climb into a full-scale replica of the SD05 and experience what it feels like to fly it. The cabin features wide wraparound windows for stunning visibility and lightweight composite seats designed by NHK Spring. A mixed reality demo lets participants virtually soar above downtown Osaka or navigate through the neon-lit streets of Shinjuku, making the future of air mobility feel close at hand. One particularly innovative feature is its modular battery system, which can be swapped out in seconds, similar to a Formula One pit stop. This means the aircraft can return to service without long charging delays. Expo staff also showcased the new Osaka Diamond Routes, a network of short air corridors designed to connect key districts like Umeda, Tennoji, Morinomiya, and the Bayfront. Passenger flights are expected to begin later this year, once the SD05 receives type certification from Japan's Civil Aviation Bureau.